I hope everyone is doing well. This is Mr. McLaughlin. I would like to add a few things to Ms. Scanlon's notes. They get some emails from our students, so I thought I'd try to throw a little bit of Mr. McLaughlin flavor to it. So we're going to talk about basic right triangle trigonometry. Hopefully you've already heard about SOH. We'll try to maybe start the building blocks of the unit circle. The first thing I'd like to talk about in the land of trigonometry is the words that are kind of in there. First of all, if you think about the word trig by itself, this word is just the study of the triangle. And the word metry over here, this one is all about the measurements. So the ancient Greeks kind of coined the word trigonometry, and if you break that down to the English version, it really just means triangles and their measurements. And I'm sure you guys are all well equipped with the understanding of triangles. There are really 6 main pieces of triangles. Most importantly, hopefully, the 3 side lengths and the 3 angles that make it up. And I don't want to bore you with all those basic geometry details, but we kind of want to start building into the concept of SOH and how that really affects the measurements in a triangle with respect to their angles and their side lengths. So one of the first things, of course, that's out there is just to kind of think about what a right triangle looks like. Lots of right triangles that we can draw, but to kind of get it going towards unit circle, I always like to put the right angle in the corner there. And I'm sure most people are well schooled with Pythagorean's theorem, so we like to say B for base, A for altitude, and C for hypotenuse. And one of the basic principles, of course, of all trigonometry is Pythagorean's theorem of A squared plus B squared equals to C squared. Straightforward concept, hopefully no big worries there. And from your study in geometry, I'm sure you guys might have heard of the most famous right triangle out there. The 3, 4, 5 would be one of our basic Pythagorean triples, and I'm sure you guys are really comfortable with that one. We've seen that one a lot before. What we really want to get into is some of these special angle measurements that are tied into trigonometry, and those happen to be our 30, 60, 90s and our 45, 90s. And really, when we get into trigonometry, we want to try to tie in what the angle measurements are with respect to the side lengths. So my big thought that I want you to kind of really concentrate in is how we label triangles accordingly to their side lengths. And one of the biggest things, of course, would be if that's big A, got to be tied into little a. Across from side A is going to be angle measurement A. And of course, across from side B is going to be angle measurement B, and most people always know that we should label the hypotenuse C and the right angle C. And one of the biggest things that we try to cover in the first couple of days of SOH is how these side lengths build these angle measurements of the triangle. Well, just like the good old classic beverage, the small, medium, large, we definitely would say that the 3 is the smallest side, and the 4 is the medium side. And of course, the 5 would be the large side, small, medium, large, which then means accordingly their angle measurements have to be that same exact connection. Angle A is definitely going to be the smallest angle. Angle B now would be our medium angle. And angle C, of course, our right angle, that's our largest one. So this is what we really like to study when we talk about right triangle trig. And there's an old joke out there that I've been telling for years. A lot of kids like to enjoy it, that the connection of what the side lengths and the angle measurements do in the land of right triangle. So we all heard of the movie. Well, Pocahontas had an evil sister. Her name was SOH. SOH, of course, just a way to express how the side lengths tie into the angle measurements. And Ms. Scanlon did a really nice job going over this very thoroughly. So when I talk about it, I also like to kind of include what this is really about and just kind of really start with one of them and build upon them. But when we talk about the sine function, the sine function is a word that just ties into how angle A would be tied into we call the opposite over the hypotenuse. So when we label triangles, we want to label them accordingly. And of course, if I'm talking about angle A, then right away we'd say that the sine of angle A is got to be the tie-in of what its opposite side measures to the respect to its hypotenuse. And the trig word sine is just that ratio that is stored onto your calculator. So we like to say right away in the land of sine, opposite would be over here, right? This is directly opposite of A. And we all hopefully know what the hypotenuse is. Hypotenuse up there, number 5, letter C. And then adjacent, the side that's not opposite or not the hypotenuse would be the 4. So we said, what's the sine of angle A? Right, of course, we say that happens to be 3/5. And we get into the trig, as Ms. Scanlon talked about, we're able to use those side lengths to tie into the angle measurements. So what we do know about trigonometry is that if there happens to be a right triangle whose opposite side is 3 and whose hypotenuse is 5, there's only one measurement that would fit for angle A. That's how triangles have to work. By angle measurement, we take the sine function, we move it to the other side. So now I'd say that, of course, angle A is equal to the inverse of 3/5. What that really means is what angle measurement has a side opposite of 3 and a hypotenuse of 5. And of course, if you go to your calculator and you double check, like Ms. Scanlon said, and you get your mode set to degrees there, we should be kind of in a good spot. So it's the second button. It's then the sine button on your calculator. And when you type this in, one of the things that I talk about with my students is, what are we typing in? Well, when I type this in, I'm saying, what angle measurement has to have a side opposite of 3 and, of course, hypotenuse of 5, and that angle measurement should be about 36.86, 36.9 degrees. So when I go back to my figure, which, we're trying to talk about, what do we just do here? Well, we made a connection of a 3, 4, 5 triangle, and we now know exactly what we would say the measurement of angle A could be. And that's, again, they're about 36.9. So 36.9, I would put right there, 36.9 degrees. And now what I'm doing is I'm solving the triangle. I'm tying the side lengths and, of course, to the angle measurements. And if I wanted to find one more angle, which, again, I think you guys probably all could figure out, that angle B up there has to be, of course, now tied into the simple math, right? So we got 180 degrees in a triangle, 90 degrees, of course, out of the hypotenuse, and we just found an angle measurement to be about, again, I'm rounding off for one decimal place, 36.9. So that missing angle now would be 53.1 degrees. So that's just basic right triangle trigonometry, and hopefully how the trigonometric word sine, cosine, and tangent tie in. And what I want to do is I want to try to start throwing some problems here at you that should hopefully kind of meet your needs of what was on the homework. So right away, when I look at this triangle, and hopefully you guys could take a second to look at it. If you need to go to the bathroom or need to take a break, you could hit the pause button down there in the lower left-hand corner and come on back to it. But one of the things we do is we like to say, okay, what do we know about these 6 trigonometric values? Well, sine, cosine, tangent have partners. And their partners just have to be the reciprocal of those functions, cosecant, secant, and cotangent. So the first thing I would do is I look at this problem, I say, okay, well, I know that my B value over here is 5, and I want A value over here is 12. So Pythagoras theorem is in full effect. The classic A squared plus B squared equals C squared. And if you remember your families of triangles there, you could, of course, without a doubt, hopefully know it's a 5, 12, 13. But let's say you forgot that from good old geometry. You would just go right to saying Pythagorean theorem is one of the best theorems out there. 12 squared is 144. 5 squared is 25. That equals the C squared. So we got C squared coming in at 169. And of course, we take the square root of both sides. We now know that C is equal to 13. So in this problem, we're not asking you to find the angle measurements. We're just asking you to write the comparison of the side lengths to the angle that has been called theta. And if you had a chance to read section 12.1 in your Honors Algebra 2 textbook, theta is just a Greek letter that they usually like to use to represent an angle. So now we should go through and label with respect to where theta is. And I always like to do is, okay, there's my right angle. So over there, that's my HYP, that's my hypotenuse. My theta is right here, so way over on that side, my OPP, my side opposite. And then down here would be what we like to call our ADJ, adjacent side. So if you memorize the function, you put some time to study, and the first thing we say is sine is opposite over hypotenuse. So opposite is 5, and hypotenuse is 13. The cosine function is what we call CAH. And again, if you want to write it up there, so got TOA. Very nice, easy rhyme to tie in how trigonometric functions, their angle measurements, and their sides are connected. So the cosine function is adjacent over hypotenuse, and the tangent function, TOA, is opposite over adjacent. So we like to call these a 2-for-1, which means if you get sine, cosine, and tangents, and you're able to find these guys, then without a doubt, you can find their partners across them. So cosine, by definition, if we're looking for cosine, it's adjacent over hypotenuse, so that'd be 12 over 13. And then we're trying to find tangent. Tangent is opposite over adjacent, so that'd be 5 over the 12. Now, the other three functions might be new to you. Didn't talk about these probably too much back in geometry, but here in trigonometry, of course, we try to push them a little bit. Sine and cosecant, these guys are partners. Because these are my classic smile when they're together. If we know what sine is, then we know what cosecant is. Cosecant is called the sine function. And of course, same thing for cosine and secant. Secant is the reciprocal sine, so that's going to be your 13 over the 12. And then finally, your tangent, cotangent, those are going to be reciprocals as well. That's going to be your 12/5. And we'll start to, of course, hopefully study those concepts and make those connections of how the trig functions, the angle measurements, and the side are tied together. All right, so I want to jump down here to this question number 3, and also try to talk a little about special right triangle trig with the 30, 60, 90s. But for this one, they're just kind of giving you pieces. So the first thing I would do is say, okay, what do I know about the sine function? Well, sine has a partner, right? Its partner, as far as its reciprocal goes, is cosecant. So if sine is 30, cosecant, that's 2 over 1. Tangent, of course, also has a partner. This one's usually pretty easy to remember. Tangent function goes with cotangent. So if tangent of 30 is 3 over 3, then the root 3 over 3 gets flipped over, and it becomes 3 over root 3. And then we do is we have to make sure we don't have radicals at the bottom. Our good old keep the bottom rational, multiply top and bottom, root 3 over 3. So now we get 3 root 3 over the 3. Of course, now we cancel off the 3's. That answer is now just root 3. So you might be saying, well, how do I get cosine and secant from this? We got to start drawing pictures. Again, if you just want to use the top up there as a mirror, I'll just draw that as my mirror picture. And I'm going to call that my 30-degree angle. And there's a couple things we like to be able to do with those 30-degree angles, but right away, we start saying, well, if we have the sine function given to us, and we think about what sine is right here, 1/2, then that means the opposite side has to have a measurement of 1. And the hypotenuse has to have a measurement of 2. Again, sine, by definition, if we talk about the word so is opposite of 1 and hypotenuse of 2. And if we do that, then we could use Pythagoras' theorem to find the missing piece. And of course, if you guys go back and think about it, we got a squared plus b squared equals the c squared in that picture. And again, this time, if we're saying we want to find out what this side length is here, it hopefully should be what we call root 3. Again, if you're not seeing that, no big deal, you just plug it in. I'll call my value 1, so that's 1 squared. I'm looking for the base of that triangle, so that's b squared. And of course, you have the hypotenuse, which would be 2 squared. So by doing that math, we get 1 plus b squared equals the 4, which means b squared is equal to 3. Subtract 1 from each side, and now b is 3. So if I go back now and just reproduce my triangle quickly, and maybe make it a little bit more clean here. There's my 30-degree angle. Side of 1 here, side of 2 there, and side of root 3 there. And this, of course, now falls into the category of a 30, 60, 90, which if we go with cosecant, it's the CAH function. Looking at problem 3 part C there. Cosine's adjacent over hypotenuse, so adjacent to the root 3, and the hypotenuse is 2, so that'd be root 3 over 2. And then secant, of course, is going to be the reciprocal of cosine. Those functions are flippers of each other. So if we got root 3 over 2, then we got 2 over root 3. We get rid of that root sign on the bottom, that now becomes 2 root 3 over 3. And hopefully now, I just took a couple of little clues about a triangle, its trigonometric values that tie a 30-degree angle to its side lengths, and I was able to construct a triangle and find all 6 trig functions. And then ultimately, of course, as we get into trig and we start to hopefully get into the drawing and the sketching of triangles, this would be a good one for you maybe to think about for a second here. So if you want to read the question there, hit the pause button and we'll come back and reconvene and see if we get the same picture. All right, Joe cast a shadow that's 15 feet long. The angle of elevation from the ground to the top of Joe's head is 23 degrees. So here comes my best art, guys. All right, here's our guy Joe. There's Joe, in all his glory. Joe is casting a shadow. Of course, shadows, we like to say, are on the ground. So if we said, all right, well, here we could say would be Joe's height. And now his shadow is being cast down to the ground. We got the beautiful sunshine shining up there and casting a shadow that is 15 feet long. Joe, of course, is standing perpendicular to the ground, standing straight up and down, so there's our right angle. If we wanted to complete that drawing and draw a right triangle right there, and hopefully angle of elevation would not be anything that bothers you there. The angle of elevation from the ground to the top of Joe's head is 23 degrees. All right, so go back to the concept of SOH here and try to spell it out for you one more time. One of these functions is better than the other 2 based upon what we're looking for and, of course, based upon what we were given. So first thing I like to do is mark our given angle. There it is. Over here, of course, is our hypotenuse. We're trying to find Joe's height, which would be our OPP, our side opposite. And then we got down here our adjacent side. So if we think about it, we're trying to find h, which is height here, right? And height is his opposite length. Which one has adjacent and opposite in it? Adjacent and opposite, right? That's got to be the tangent function. Both sine and cosine need the hypotenuse. We don't have the length of the hypotenuse. They have not given that to us. Let's not waste time finding the hypotenuse, and we're just trying to find out what Joe's height is over here, which again is opposite. So I would write down the word TOA. And in my brain, I'd be thinking the tangent of a angle measurement is tied into its opposite over its adjacent side lengths. And this has to, of course, be what we call right triangle trig. SOH only works in right triangle trig. And if we start to spell that out, then we say, okay, we got the tangent, and the angle we're given was 23 degrees. The opposite side is what we're trying to find. That's his height, so if you don't mind, I'm going to call that h. And then, of course, a is what the adjacent side is, which would be 15. Now we have our standard proportion. And in right triangle trig, proportions come to be our best friends when we're trying to tie pieces together. And if we simply cross multiply here, the math should be pretty easy. Take the h, which represents Joe's height, multiply it by 1, which would be h, and then cross multiply over here as well. I always like to take the numerical value of 15, write that down first, and then write down the value of the trig function second. And now we'll go, of course, going back to our calculator to find this height. How tall do we think Joe is? How tall is the average man? Maybe about 6 feet tall. Let's check it on out, right? So on your calculator, we're now taking 15, and we're multiplying it by the tangent of that 23-degree angle. And he's about 6.367 feet tall. If you don't mind, I'm going to call that about 6.4. And for conversions, if we went to feet and inches, we get a little bit technical, but if we subtract the 6 out, so if he's that much of a foot, and of course there's 12 inches in every foot, so we'd say Joe is about 6 feet 4 inches tall. 6.4 is, of course, a nice approximation. 6.4 feet was actually about 6.4 inches there, right? Yeah, 6 feet 4 inches tall would be probably his best height measurement. All right. So again, about 6 feet 4 inches tall. All right, so that's just some basic right triangle trig there. Again, the lesson's going to get a little bit longer. I do want to talk about right triangle trig and how it applies to unit circle. So if you take a break again, feel free hit that pause button there, and I'm going to kind of move into what we call the unit circle here. All right, so what I've done is I've constructed the first quadrant of the unit circle. And of course, if we think about what we call the unit circle in general, a unit circle is a circle that has a radius of 1. And now this really started to tie in your 30, 60, 90, 45, 45, 90 special right triangles. So what I'd like you to do is just take a look at this first spot here. And if you notice, of course, there are some more spots as we move up on our unit circle. What we like to do is we like to start off by just kind of pulling out a triangle from the unit circle with respect to its base. And realize, of course, that the base of this triangle is always going to be the x-coordinate. And then if we want to talk about the height of the triangle, well, the height of the triangle, of course, is going to be the measurement that goes from top to bottom. So what you're noticing here is that this base is not going to be 1. It's going to be definitely less than the value of 1 there. And our hypotenuse now is going to be here. So if you look at that first quadrant, we like to say that in the unit circle, we like to work with triangles that are formed from 30-degree angles, 45-degree angles, and 60-degree angles. So we have 3 connections of triangles that we want to get to in the unit circle. So first of all, if the radius is 1, then that means that value there is 1. And this first spot up here, the measurement of that angle happens to be that 30-degree measurement. So what we're looking at now is a 30, 60, 90 right triangle. And of course, if we look at that piece there, and we've done some work with 30, 60, 90s, we hope we have a good feel for them. So if I just pulled that out, and I put it right here, and said, okay, that's a 30, that's a 60, that's a 90, and now we have a hypotenuse of 1. What do the measurements of these other 2 sides have to be? Well, that's your x, and that's your y. And if we measure the 30, 60, 90, and we had some memorized the side lengths and how the ratio of their sides fit together, we hopefully might remember that the value of 30 degrees is tied into SOH. And of course, if we wanted to try to find out what this is and what this one is, we could use SOH trig to do that. So right away, we like to say, what would be the value of y? SOH, sine is here, right? The sine of that 30-degree angle is equal to the opposite side, which is y, over the, of course, hypotenuse, which is 1. And if we do that for cross multiplication, we get y equals to the sine of 30 degrees. And if I wanted to start this right triangle trig concept, I'd be thinking about that spot on the unit circle being an ordered pair. Coming out of the chapter on conics, and find a spot on the arc of a circle, it's an XY coordinate. So one thing we like to tell all kids to do, if you get the chance, of course, memorize some things, but check out what the sine of 30 degrees is. It's 1/2. It's a very popular measurement in the land of trigonometry, that 30-degree angle measurement. So when we think about that 30-degree angle measurement, we say, okay, well, that means that this y value has to be equal to 1/2. I'll go over here and say, okay, well, now that's 1/2. And if you want to, of course, you can now do cosine of 30 degrees, and you can find adjacent over hypotenuse. But probably the more meaningful would just be doing Pythagorean's theorem. So this spot now is square root of 3/2. And I will try to show that to you here real quickly, but if we said we want to find out what this value of x is down here, and we happen to know, of course, what the y coordinate is, that this guy up here is 1/2, then we are definitely building right triangle trig. We got the measurement of a hypotenuse of 1. We got, of course, a height of 1/2. And then we need to find out what that x-coordinate is. So if you did Pythagorean's theorem real quickly, we'd say, okay, well, the x squared is equal to the y squared added together. X squared plus y squared is going to equal to the radius squared, which now means, of course, we're looking for x. We know what y is, right? Y is coming out as a half, and we know what the radius is. The radius is 1. Now, if we square those quantities, we'll have that x squared plus a fourth is equal to 1, which means if we subtract a fourth from each side, 1 minus a fourth is 3/4. And if we take the square root of both sides, we now have that our x value equal to the square root of 3 over the square root of 4. And of course, I think everyone knows what square root of 4 is. The x-coordinate is the square root of 3 over 2. And that would be our basic beginning of what we like to call the unit circle. And I could keep on going on for hours and hours and probably bore you to death about the unit circle, but what happens is now these triangles start to, of course, rotate from one quadrant to the next. And we like to say that we could definitely measure quadrant 1 of what we like to call right triangle trig. So I want to move on to the next spot. And of course, as I move on to the next spot, I want to kind of clear the board here and say, hopefully everyone's comfortable with what we just did there, right? Feel free, of course, to go back, hit the pause button, take a look again, but we hopefully just proved that this angle measurement here of 30 degrees in that spot has to have an ordered pair that has a base that goes out to the square root of 3 over 2, which again is pretty close to 1, and the height there is 1/2, that triangle has to be formed by those measurements. And if we think about that for a second and we go back to what we were talking about before, this would be the short side. This, of course, is the long side, and that's the medium side. If we talk about small, medium, and large, in this position, the small side is 1/2. The medium side is root 3 over 2, and of course, the long side is 1. And if we kind of put those in order and just kind of take a look at them on our calculator again, I think that should hopefully make a little bit of sense to you. Come on, Mr. Calculator. All right. There it is. So we all know what 1/2 is. That's my small side. What about the square root of 3 divided by the 2? And of course, we all know what 1 is. So again, if you kind of classify those side lengths, that's the small guy, there's the medium guy, and there's the large guy for our side lengths. And again, if I think about it, the small guy is across from the side of 30 degrees. The medium guy was across the side of 60 degrees, and the large guy, of course, the hypotenuse of our triangle unit circle, was a radius of 1. Right triangle trig is pretty amazing of how triangles fit together with their side lengths, and of course with respect to their angle measurements. All right, so let's move on to that next spot there on that unit circle. Sorry, I got a couple files pulled up here, but let's go back to this guy now. So, okay, well, what's going to happen with that guy right there? Well, in that next position now, we get a whole different look at the triangle. And hopefully, as we begin to look at this next spot on the right triangle in the unit circle, we like to say that this angle measurement here is our classic 45, 45, 90. It's 45 degrees, which then makes that 45 degrees. So if we got a 45, 45 degree triangle, and this hypotenuse has a radius equal to 1, then if you memorized it before, we would say that this becomes root 2 over 2, and root 2 over 2 as well. Again, that's coming from Pythagorean's theorem, and hopefully you kind of have heard about that, or please at least check it on your calculator. And then when we go to that next spot, which would be right here, it's very interesting what happens to this third triangle that we now have in the unit circle in quadrant number 1. So the TOA, of course, still in effect, but now our triangle looks like this. If you take a look at that triangle, what happens with this one is it's still a 30, 60, 90, but the 60's here now. And of course the 30's up there. So that means that this ordered pair that was in the first spot, which was a 30, 60, 90, and now we're looking at a 60, 30, 90, those guys just switch spots, and your base becomes 1/2, which would be your small side, and your y value, of course, your height is your medium side, root 3 over 2, and we still have a radius of 1. So this, again, is just basic stuff, guys. I'm just trying to introduce the unit circle, and there's a lot of things that you can kind of do on your own to memorize it, but if we get those spots in place, you can hopefully start to develop a nice theory about what happens in the other 3 quadrants. And those order pairs are going to be the same value, just going to start to change what positive or negative on the respective quadrants. And then, of course, I like to kind of just go back here to these 2 spots. These happen to be my 2 favorite spots on the unit circle. I call these my blue babies right there. Those blue babies, of course, have a radius of 1. And since they're lying on an axis, we'd say here, at what we call the 0 degree mark, we're at the ordered pair 1, 0. And over here, at the 90 degree mark, we're at the ordered pair 0, 1. And to kind of finalize what was going on in these particular spots, we like to say 30 degrees, 45 degrees, and 60 degrees in quadrant number 1 are the building blocks of the unit circle. And again, unit circle of a radius of 1 must have x's and y's that make up their legs. If we go back to, of course, this 60-degree angle to kind of summarize it, the x value, which would be the base of the triangle, is a half. And the y value, which would be the height of the triangle, would be square root of 3 over 2. And that ordered pair that checks into this spot in space would have to be a movement of a half for its base, and of course a height of root 3 over 2. I have attached a couple of things for you guys to take a look at. Again, this lecture went for 30 minutes, so a little bit on the excessive side, but some great stuff are done in your textbook, and of course feel free to email your teacher. If you have any questions or any thoughts about the unit circle, I will have a couple attachments for you guys to take a look at. We do have spring break coming up, so everyone stay well and stay healthy, and hopefully we'll see everybody soon. Mr. McLaughlin, signing off.